Welcome to qnawire.
Right. So in NMR spectroscopy, what we see is that on a scale of ppms, we're going to see different peaks that are going to arise from the signal of the device, and each of them are going to have different heights. Now, what those represent are the number of hydrogen atoms that are going to appear on each side, because the height of the peak and to be more specific, the area within the peak corresponds to the number of hydrogen atoms from that signal. This means that the larger the signal, the more hydrogen atoms contribute to it. So, how do we calculate this value for NMR spectroscopy? And the answer is quite simple. Actually, what happens is that the software, what it does is that it starts to calculate numerically the area underneath the curve while the NMR spectrum is being obtained. So with that information, it can tell you in a more accurate way what is the total integral under this peak. In older days, the way that people used to do it was employing different numerical integration techniques, for example, using trapezoids, in which, let's say that we have a very nice zoom of one of the peaks of the NMR spectrum, what people used to do was calculate different heights and sum up the areas that they were able to find with this technique. As you can see, in order to get an accurate value for the area underneath this curve, what you need to do is to measure a lot of rectangles, and of course that is not practical at all. So nowadays the computer software readily gives you the value for the integral after the device has been calibrated. That would be all. Thank you very much and have a good one.